In this video lecture, we are going to see what is order and degree of a differential equation. Now, let's begin with the order. The order of a differential equation is defined to be that of the highest order derivative. Now, here is the word highest order. Alright, now what does that mean? You see, an equation have specifically a differential equation have the differential terms like dy by dx, right, or dy by dt, or dx by dy, etc. Right? Now, if we see here this term, what does that mean? Here it means d by dx of y. We write this as dy by dx. Means we have found the derivative of y with respect to x one times, right? Because we have applied this d by dx of y only one times, so we get dy by dx. Therefore, because we have applied only it one times, so it is written as dy by dx, and this is called as first order derivative. First order derivative. All right. Similarly, we can differentiate this term again the second times. All right, what we get d by dx of dy by dx. Now this is known as second order derivative. All right, why it's called second order derivative? Because see, here we have applied this one times. All right, so it's called as first order derivative. Now this is the first order derivative. Now to this first order derivative, we applied again the dy by dx, right? So we are differentiating this y with respect to x the second time, right? So we call it as second order derivative, and this d by dx of dy by dx is written as, let me write here, this is written as d square y by dx square. Okay, now if we differentiate it the third times, we apply d by dx again, we get d3y by dx 3. All right, now here we call this as second order derivative. Now because this is the third time, we call it as third order derivative. All right, now based on our definition of the order, we have the word highest order. Now a differential equation can contain only one. All right, it can contain only one, or it can contain two. It can, a differential equation can contain this term too. Okay, we don't know, maybe this two, or it can contain this two, or only this, or all of these terms together, like in this equation. Let's see here. Now how many derivative terms are here? By derivative terms we mean this dy by dx, dy by dt, whatever. If it is a derivative term, now we have to see how many derivative terms in this equation. If we see in this equation, here is only one derivative term, and it is only this, right? There is no more derivative terms, so the highest order is this one. Okay, so this differential equation is first order differential equation. Okay, we write it as like this, first order differential equation. Okay, now let's see in this equation. Now here we have two derivative terms. One is this and one is this, right? Now which one have the highest order? All right, now this term here, this is the first order derivative and this is the second order derivative. Okay, now the order of this differential equation is going to be the highest order derivative. This is a derivative 2, this is a derivative 2, but here this derivative is the second order derivative. That's why this whole differential equation is going to be second order differential equation. Okay, this was first order, this is second order differential equation, and now this one you can see there are two terms and the highest one is this 3. So the whole differential equation is called as third order differential equation. All right. Now let's see more examples. Let's see more examples like here. Dy by dx whole square plus 3 dy by dx plus 2y equals 3. Now, can you tell me the order of this differential equation? Don't say this is the order, okay? This is not the order. This term is the power, right? Right, we write the terms like x square, x cube, y cube, okay? These are not the derivatives. This is over this bracket is 2. So this is not the order, okay? This is the power and power is not the order, okay? This what is order is the how many times you have derived this y with respect to x, how many times you have derived you have derivative of this y dependent variable with respect to the independent variable. Here this y, it is like this d by dx of y, right? Isn't it? It is the same. We write it as dy by dx. So only one times d by dx is applied. So here this is first order derivative. Now here again this is only one times d by dx is applied to the y. This is again the first order derivative. Therefore this whole equation becomes first order differential equation. Okay, note that this is power. Okay, this is not a derivative. Okay, now let's go to the another concept, degree of differential equations. Okay, degree of differential equations. Now what's written here, degree of a differential equation is the power of highest order term. Now see here, note the difference, power of highest order. Okay, the highest order, what is the power of the highest order derivative when converted into a polynomial form? This one is very important. Okay, if your differential equation is not in the polynomial form like this, d square y by dx square plus 3 dy by dx plus 2y equal to 0, this is in polynomial form. Okay, what does it mean, dy by, so if, anyways, if you want to find the degree, two things are very important. Dy by dx are not clubbed. You have to make sure dy by dx terms are independent. Okay, they are not like clubbed with other terms like plus 3 whole cube. Okay, this should not happen. If this happens, you have to apply these any formulas and you have to separate this dy by dx out of this bracket. Okay, you have to remove it from the brackets because that's the polynomial form, right? And their power is an integer like 1 2 3, like this, dy by dx whole to power 3. This is good. Now if you see dy by dx power 3 by 2, no, you have to convert this 3 by 2 anyhow, because 3 by 2 is what? 3 by 2 is 1.5, and this is not an integer, right? The term is integer. So you have to do something with the 3 by 2 so that it is no more a fraction, it is an integer, okay? Like you have under root of dy by dx. What's under root? It is dy by dx power 1 by 2, okay? Again, 1 by 2 is a fraction, 0.5. You have to convert this this 1 by 2 fraction or this root, okay? You have to remove this term from the root, all right? You have to remove it from here, then only you can find the degree, okay? Now let's see some examples here. Now see example 1 here. What's this? D square y by dx square plus 3 dy by dx plus 2y equals 0, okay? Now see here. First, let's see the order, okay? Order is based on what? How many times you have differentiated y with respect to the x, okay? The highest order derivative will be the order of the whole differential equation, okay? Now here it is 1 times, right? Here it is 2 times. So what is the order? Order is 2, right? Now, what is the power? See here. Degree of a differential equation is the power of highest order derivative. See this highest order here. Now the highest order is here is order is 2, here is 1, right? Now the highest order is which one? Highest order here is 2. So what is the power of this term? The power of this term is 1. You know, like if I write let me write here, if I write x here, what is the power of it? 1, okay? Because when the power is 1, we don't write it, right? We automatically know, I mean we naturally know, if one, even the 1 is not written, we still say the power is 1 here, okay? Now here in this term there is no power written, means the power is 1 here. We didn't check the power of this term. Why? Because this one is not the highest order term, right? We don't have to do anything with this term, we have to do with this term, because this one is the highest order derivative, and this power matters. We don't care about this one. This power matters. Since the power here is 1, so degree is 1, right? So the degree is 1. Understand? Now let's go to another problem. Let's go to this problem number 2. Here is, well, let's first see the order. Here it is y is differentiated with respect to x 2 times, right? Because here is 2 means it is differentiated 2 times. It is second order derivative. And here, what is happening here? Here the order is what? Here the order is 1, okay? Because y is differentiated with respect to x only 1 times, right? And here is 2 times. So which to find the order, we have to deal with the highest one, okay? This is 1 and this is 2, means highest is this one, right? So it defines the order. That's why, because it's 2, so the order is 2, right? Now what's the degree? I have told you to find the degree, you don't, the dy by dx terms, the differential terms must be free from these brackets. They must not be clubbed with anything here. Like we have here the bracket, and this is the differential term, right? Now this dy by dx term must be taken out of these two brackets, okay? Only then we can find the degree. Please remember that. Now how do we do that? Let me get some space here. Here. How do we do that? How do we do that? Now here is 1 by 4. Can you see, if we raise the whole equation with 4, raise left and right side by 4, what we get, d square y by dx square power 4, right, is equal to y plus dy by dx power 6 whole power. Here is already 4 and then we multiplied by 4, right, because here the power is 4 and here the power must be 4 too, both sides. Now this 4 and 4 cancel out. Let me show you this color. This 4 and 4 cancel out, so what are we left with? Sorry, uh, take it a little bit. Okay, now here what we get, d square y by dx square power 4 is equal to y plus dy by dx power 6, right? This 4 and 4 goes cuts. Now here you can see this dy by dx term, this dy by dx term is not clubbed with any bracket with other terms, okay? Like here it was clubbed with this y, then it was raised to the power 4. Now here it's independent of other terms, it is not clubbed with other terms with the help of root or powers or something. Here it is independent term, here it is independent term. And another thing to check is what, here the power 6 is not a fraction, okay? This is what, this is an integer. Here it is integer 2, so we are good, okay? Because the rule to find the degree is what, it must be integer, okay? And it must also be independent term, independent dy dx term. Now here we fulfill both the conditions. These two are independent and the power is integer 2. Now which one is the highest order? Here the y is differentiated with respect to x 2 times. Here the y is differentiated with respect to x only 1 time. So which one we are concerned with? This one. We have nothing to do with this one, okay? This term we have nothing to do, because this one will decide the power and the order and the degree. Therefore the order is 2, right? Because this is to the highest order is this, so the order is 2. So here I write order is 2. Now what is the power of which term? The highest order term, okay? We don't have to see this power 6 because this is not highest term. This one 2, this is the highest derivative term, so we are concerned with the power of this. We have nothing to do with this power. This one is highest, so we are concerned with this 4. Therefore the power is 4. Power means degree, therefore the degree is 4. Understand? Now let's move on. Take this little above. Okay, good. Now let us see problem 3. Now dy by dx term is not clubbed with other terms with the help of those brackets or something, okay? Here uh, here this y term is differentiated with respect to x only 1 times, okay? So the order is 1. Very good. Now which is the highest order derivative term? We have only one term here, this term, right? And what is the power of this term? this term is raised to the power 1. Okay, when the power is 1, we don't write the 1. That's why we understood that the degree is 1. Okay, now let's move on. Let's see this differential equation. Now here you see we have two differential equations. One is this and another is this. Now here you can see the order is 2. Here you can see the order is 1. So which one is the highest, 1 or 2? The 2 is highest, so order is 2. Very good. Now dy by this term, what is the power of this term? Power of this term is 1, right? Because when the power is 1, we don't write it. Therefore, the degree is 1. Okay, you have to remember degree is power, right? Now let's see this equation. Okay, can you guess? Now you can see here I have written order is 1 and the degree is 2. Do you wonder why? Let me show you how. This equation, let's simplify it. Now here, if you simplify it, you will see something like this. Dy by dx power minus 1, right? Because this is in the denominator, dy by dx, we get it to the numerator, so obviously the power has to be minus 1. But remember, to find the degree, this minus 1 must not be there, right? Because it should be only integer. The power should only be integer, and minus 1 is not an integer. Remember, integer is only 1, 2, 3, 4, 5, and so on, right? The negative numbers are not integers, so the first condition fail. What do we do? Do we quit? No, we don't quit. What we have to do, we have to convert it such a way such that this minus 1 disappears. Okay, how do we do that? Just think, do something. You can do anything. Okay, in mathematics we can do anything. We can, as long as the things we are doing it on both the left side of equal sign and the right side, if we are doing equally, that's no problem. Now see, now think what you can do here. Any idea? See how we can do this. Let's multiply it by dy by dx on both the terms, both the sides. Let me choose another pen. Multiply both sides by dy by dx. Why? Because when you multiply this term, power minus 1 with dy by dx, here the power is how much? Here the power is 1, right? This is 1 basically. And when you multiply this, 1 and minus 1 cancels out, so we get rid of minus 1, because that's what we want. We want to get rid of minus 1. That's why I decided to multiply it with this term. So let's do that. Here we go. We get this dy by dx multiplied by dy, oh sorry, it's plus y multiplied by dy by dx, right? Now we multiplied the left side, which is equal to the right hand side, dy by dx power minus 1. We multiply this term with dy by dx. So what we get? Here we get dy by dx power 2, right? Because we multiply this with this term, and then we distribute the multiplication, right? Plus y dy by dx is equal, now here is minus 1 and here is plus 1. They cancel out when we multiply. Minus 1 bases are same, powers are added, right? Minus 1 plus 1 is equal to 0. So here we get 0. Now see here, this dy by dx term, right? Here is 1, which is an integer, very good. Now here is 2, which is an integer, very good. Now dy by dx is not clubbed with other term with under root, square root, right? Now we can see this is integer and dy by dx terms are independent, so okay, they are not clubbed with other terms. Therefore, now which one? Here is dy by dx, here is dy by dx, and here is dy by dx again, right? Therefore, the order is 1. That's why I have written here, that the order is 1. Okay. Now, because they are both the same, dy by dx, the order of this equation is 1. Therefore, we can choose the highest power here. Okay. This was not the case before. Because before the terms were not the same, dy by dx. Now here you can see, because the power is 2 of the highest derivative is 1, right? The power is 2, therefore the degree is 2 again. All right. Let's continue here. Now this term, okay, I didn't need to do that anyways. This term, differential equation, here dy by dx is connected by natural log ln, right? But this cannot happen. Okay, we have to set it free. What we do, uh, we we use e to the power the terms on both sides. Okay, that is, we raise e to the power ln of dy by dx. We raise it left side, this equation, to the power e. This is the left term, right? And we have to do the same to the right in order to balance. Now why I did that? Because I know this e and ln, when you see these together, they cancel out each other, right? So what we are left with, dy by dx equal to e to the power ax plus by. Okay, now here you can see the power is 1. Okay, because we have only dy by dx. This is the only differential term. Okay, we have only one differential term here. 1 is a power which is a what? Integer. So condition 1 is pass. Okay, now what is the condition 1 is pass? Now what is the second condition? This dy by dx have to be independent. Yeah, of course this equation is independent, so condition 2 is pass 2. So we can say, because y is derived with respect to x only one times, so the order is 1. That's why I have written here order is 1. And this the power of this term, highest order derivative, is 1. That's why the degree is 1 again, right? Let's move on. Let me get some space here. Perfect. Now let's talk about this differential equation. The differential equation is this, right? This is our differential equation. Show you this. This is our differential equation. Okay. Now here you can see this 1 plus dy by dx power 2 by 3. Now the problem is, again, this is clubbed with this dy by dx term is clubbed with 1 and then raise it. But we don't want that. We have to release it. So how do we raise it? Can you guess? You can do anything to just get rid of this. Any idea how are you going to do that? Let us raise this to the power of 3. What we get? 1 plus 3 dy by dx power 2 by 3 multiplied by 3. Okay, I multiplied the powers with 3 on both sides, right? Multiplied by 3. Okay, so because I have multiplied left side term, I have to multiply the right side term to d cube y by dx cube power 3 into 3, right? Implies here we get this 3 and 3 cancels out. This 3 and this 3 term cancels out. We are left with 1 plus 3 dy by dx square is equal to 4. Oh, sorry, here is only one term, right? This term, why I did that? 4 d cube y by dx cube whole power 3, right? So what are we left with? We get this is a plus b whole square, right? This is a plus b power 2. This is a square plus b square is 3 square is 9 dy by dx whole square plus 2 ab, right? 2 into 3 dy by dx is equal to, now let's distribute this power to the individual terms. Here we get 4 to the power 3 multiplied by d cube y by dx cube power 3, right? Now see here, so what we get finally, we get 1 plus 9 dy by dx square plus square plus 3 2 is 6 dy by dx is equal to 4 cube. Let it stay like this, we don't care. D cube y by dx cube power 3. Now here you can see the terms dy by dx here, d cube y by dx cube, d3y by dx3, they are independent, right? So the condition 2 is satisfied. Also here the derivative power is 2, which is an integer. Here the power is 3, which is again an integer. So the first condition is satisfied too. Now let's see which is the highest order derivative. You can see in this term this y is derived with respect to x only one times. So here this is first order derivative term, right? This is first order, and here it is, this y is derived differentiated with respect to x 3 times. Here is 1 and here is 3. So what's the highest order is 3. That's why I have written here order is 3, right? Order is 3. Now we are concerned with the highest order derivative, which is this one. Okay, we have nothing to do with this term. Now what is the power of this highest order derivative? It is 3. So how much is the degree? The degree is 3. That's why I have written degree is 3. Okay, so that's it for this lecture. Thank you. If you have any problems, you can contact me, and as always you can find these notes, you can download them. Okay, download them in the description or in the comments. I will provide the link to download this PDF file. Okay, thank you. That's it. See you in the next class.